Too long. Please stop talking. Thanks. Okay, so let's just talk about real quick. I posted homework for Friday. I thought should be there. Okay, so your homework is 2 parts. You're going to keep answering reflection questions in that same reading. Reflection questions 4 through 9, that same reading. So read that taxing again. So this Friday we're going to start digging into that tax function. It sets a really nice groundwork for our next kind of section of the course, which is accumulation. So read that taxing again, answer reflection questions 4 through 9, and get your questions answered on 1 through 3 if you were unclear about 1 through 3. And then the second part I will explain at the end of class. You're going to make a GC file, and that's going to be able to create any piecewise function. And I'll show you that at the end of class. Okay, and then you're going to be submitting through email the way we did that about a couple weeks ago when you submitted GC through email. So that's for Friday. Any questions about homework? Logistics. Okay, so we left off last time. So top hat's going to be kind of right in the middle of class today. So just kind of be ready to do a top hat question somewhat in the middle of class. Here we go. So we're currently talking about piecewise linear functions. Basically, several linear functions pieced together, right? Okay, so we have a constant rate of change. That's linear function, but then it has a different constant rate over different intervals. So we have a constant rate over the first interval, then a new interval, we have a new constant rate, etc. So this is what we call a piecewise linear function. And we had this example last time that we kind of got rushed at the end, and I want to revisit this and really understand it, okay? So in this situation, we saw that X was the number of gallons added to the tub, and then Y was the resulting Y was then the height of the water. Okay, so delta X will be a change in the number of gallons. Delta Y will be a change in the height resulting from adding water or taking away water. And then K is our constant rate of change, and that will be height with respect to volume or in inches per gallon. Okay, and so then what was different about this problem in terms of K then? There's 2 of them. There's 2 of them, right? So we've got a rate of change of height for adding water in the bottom part, and then suddenly we get to the step, and we're adding more water, and that rate of change of height is different. So this fits this idea of a piecewise linear function, okay? Okay, so let's kind of work this out. So X is the number of gallons, Y is the water height in inches. Let's put together some ordered pairs before we're going to build the piecewise function. So let's do some ordered pairs here. So what is one corresponding pair of gallons and height in inches? It's the easiest one we got. When you don't have any water in there. So and this was in inches. When there's no water added, the height is 0, right? And then we saw that when we get up to, it's 16 gallons, or sorry, we figured out that that step was 16 inches high, and that corresponded to, we did this last time, 128 gallons. Okay, and then in that range, so as X changes from 0 to 128, we came up with a constant rate of change of how much the height changes per gallon of water. And we found that to be 1/8, 0.125 gallons per inch. Okay, so that's like our K1, or for K for below the step. So can you describe the meaning of that number kind of in as it applies to delta y equals k delta x. So I'll write that down. What does k mean when we think about delta y equals k delta x? Tell your neighbor. What does that number 0.125 mean? Thinking about this very important relationship that we've seen, delta y equals k delta x. Tell the person next to you. Go. Okay. So related to that right there, related to delta y equals k delta x, what does this number 0.125 mean? Volunteer. Yeah, Caitlin.
Our average gallon average 40.6 inches, it'll grow by 0.125.
That's a true statement, but it doesn't really reflect that right there.
I was going to say the change in y is going to be 1/8 as fast as the change.
Okay, so the change in y is 1/8 as fast as the change in x. Y changes 1/8 as fast as the change in x. Okay. What about in the jacuzzi context? So can anyone describe that number in light of delta y equals k delta x, using the terminology of the context of the jacuzzi? So how about someone in the back? Give it a try. Please.
The inches or the height of the water will increase 1/8 of an inch per gallon added in the jacuzzi up per step.
Okay, it doesn't have to be 1 gallon. That's true, it's inches per gallon, but the whole point of this expression is it doesn't have to be 1 gallon, right? Tell me.
Change in the height in inches equals the change of gallons, I don't know, relative to 0.125.
Okay, getting there? Someone else want to? Yeah.
Relative size of the change in y, change in x.
Right. Okay, we want to talk about the jacuzzi. Okay.
Change in water height in inches, relative size to the change in the number of gallons.
Okay. So that would be what you said is absolutely true. Would be more like what you're saying, like is this, which is true. But how? Go ahead.
The change in water height in inches is at a constant rate of 0.125 or 1/8 with respect to the change in number of gallons.
Okay. Yeah. Getting there.
Okay, so for any point of x, it's going to be times by 1.125, and that's going to be the change in y.
Any point in x?
I mean, the change in x.
And what is the change in x?
Number of gallons.
Number of gallons. So if you change the number of gallons, then
as the jacuzzi fills with water, the height of the water changes in 8 times faster.
okay. So yeah, so that the height. Okay, so the height is changing 1/8 as fast as the water's filling up in gallons.
Yeah.
Okay. More. This is great. Anyone want to offer up another? Yes, please.
So for any specific amount of change in x, you can find the change in y by multiplying by 1.5.
Right, but talk to me in terms of the jacuzzi. Talk to me in terms of that's perfect. But how about in the jacuzzi?
For any specific amount in the change in gallons, you can multiply by 0.125 to get the change.
Right, the change in height of water in this bottom portion will always be 1.25 times whatever amount we add of gallons. This change in height, delta y, will always be 1/8 or 0.125 of an added amount of water, whatever gallons we add. The change in the number of gallons. Okay, and so then it turns out, so we said that the total water height was 35, and it turns out, we're not going to take the time to do the math, but that's 550 gallons, okay? So when you get to 550 gallons, that gives us this maximum height of the water of 35. And we found a second rate of change because the surface area is bigger now above the step, so it's going to be a slower rate of change, and we found that to be 0.04, yeah, 0.045. Which says that the change in water height is always 0.045 times the change in volume of water, or times the number of gallons added. Okay, so this says the change in water height is always 0.045 times whatever amount of gallons you put in. Okay? So then let's build, so we're going to build this piecewise function based on our, so you worked in your, we did it on Friday and on Monday in the quiz, and then we went over the quiz and you worked in your homework and you did lots of questions where you built this form of the line. So we've paid our dues, we've done the heavy lifting, and now we can use it. Okay, so now we can just use it. So we want to make a piecewise function for this. We're going to have one piece when x goes from 0 to 128. So let's write that down. So 0 is less than equal to x is less than or equal to 1. That's going to be one of our pieces. And then from 128 all the way up to 550. Okay, so from 0 to 128, what's our rate of change? 0.125, 1/8. And then what is this A, B? It's some ordered pair in that range. So use 0, 0. Okay, and then now in this range from 128 to 550, what was our constant rate? 0.045. Okay, and now we need a corresponding number of gallons and height. Use this one. So we're going to do x minus 128 plus 16. Okay, and so that's our two pieces of our function, and so we'll name this, let's call it W. Capital W for water. So the name is W. So W of x equals this right here. What's that?
Yeah, shouldn't it be above it? Because the bottom restriction has to be greater than 128, and you're giving it at 128.
Yeah, so xx is what goes into this piece of the function has to be greater than 128.
But it is.
What's that? What's that?
But the point you use isn't greater than 128, so it would be excluded.
Okay, so we would not put 128 here. We'd have to put a number greater than 128. According to this, every number greater than 128 could be an input.
Well, no, I mean for the ordered pair you use for the input into the formula for A and B.
Okay.
Shouldn't it be greater than 128 to fit within the restriction?
Okay, so when we fill this up, how many gallons go in there? 128. And so then the additional number of gallons is going to be starting from 128 and going up from there. So when we put in 128, it's a height of 16, fills up that bottom portion. And then for more gallons than that, that's going to be above that height of 16. So when we see the graph, maybe it'll help. When you see the graph, okay? That point, 16, 128, is actually on both lines. That point, 128, 16, is actually on both lines. It's on that line, and it's on that line. But plugging in 128, we're going to plug 128 only into the top line. But that second one does start there. It starts there, okay? All right, so let's put this in GC. Let's talk about that. So this is the function we want to put in GC, and I'm going to show you how to do that. Okay, so we named it W. I'll name it F here. So, or no, name it W. So W, and then how do I get parentheses for function? Control 9, and let's use something else, just a placeholder. So let's use A. Okay. No, let's use X. Let's not confuse things here. So we'll just use X. Equals. Okay, so now what you do is you're going to hit, if you've got a Mac, it's Control Control A. If it's PC, I think it's Control Shift A. Is that right? Okay, thank you. A little bit bigger. Okay, so what was our first line? 0.125. So you're going to type this in. X minus 0, just so we follow the form here, plus 0, which ends up being 0.125x. And so what we need to tell a graphing calculator is that this is going to apply only if x is between 0 less than or equal to x less than or equal to 128. So we need this if statement. It's because we're not telling it to graph over a certain range. So we use the comma when we're graphing, and we say we only want to graph this part of it. But here we're defining the function. So what we need to tell a graphing calculator is when only if x is in between here, you're going to use this rule. So that's why we need if. Okay, that's why we need if. And then our second statement will be what we said: 0.045 times x minus 128 plus 16, and then if, and so now we're going to start at 128, but not include that, because the number of gallons 128, that's going to be the first line. It can't be both. It can't be both. It's got to be one or the other. So we're going to include 128 on the first line, and then just a little bit more water than 128. It'll go to the second line. Okay? So 128 is less than x is less than or equal to 550. Which you're just trusting me. That's, we don't want to go through the math. Just trust me, that's how many gallons get us up to that 35 inches. Okay? So that's how you create a piecewise function in graphing calculator. So you, after the equals, Control A, and you can just keep doing Control A for as many pieces as you have. So we only had to do it once, because we just have 2 pieces in this function. So I'm going to turn off the graph paper here. Okay, so then how would we graph that? So how are we going to graph our W function?
I equals function name.
Okay? And if we hit enter, we should get it. Okay, so what I want to draw your attention to is that you don't want to see this function that you wrote as this just 2 sticks, right? Just 2 sticks glued together. So, when you write out all that stuff, you get 2 sticks glued together. What do you get instead? So what's a better way to conceive of this graph rather than it's just 2 sticks glued together? What's a better way to conceive of this? Yeah?
A bunch of horizontal bars.
A bunch of horizontal bars?
Yeah, like steps kind of.
Step levels? A bunch of levels? I'm not sure what you mean. This graph, so this thing that we've drawn in blue, how do we want to think about that? Kenny?
2 different slopes.
Okay, 2 different slopes. What are you looking at when you look at those? When you look at those 2 blues that look like sticks, what are you really looking at? Some of you said it. Points. Okay? Points. And where do these points come from? Where do they come from? Okay, so the points emerge as we fill. Oh, come on. There, I got to turn that on. All right, there we go. So the points emerge and build the graph as this thing fills up with water. So this is the way to think about it. As it fills up, along the way, it's generating points and the graph emerges, right? So let's talk about what. So back down here, say right now, 89. This is 89 gallons. What does this point mean? So what does that point on the graph mean? Talk to the person next to you. What does that point mean right now? Okay. What does it mean? Somebody knew. What is the meaning of that point? What is the meaning of that point? It's really important. If I were to say it, you'd be like, oh yeah, it's really easy. But can you say it? Can you say it precisely? And what is the meaning of that point?
The corresponding relationship between 89 gallons and some of the 89 gallons.
Okay, so he's saying it's 89 gallons and the corresponding height of the water. Good. Okay, so 80. So how can we write that? So without our calculator, we could say 89 and what could we write? Yeah. This is perfectly valid. And that W of 89 means, what does that mean? Height of the water when there's 89 gallons. When there's 89 gallons, it's the height of the water. Okay? How can we use graphing calculator very quickly to find this height? What can I do? So what should I type to very quickly find W 89? What's that?
Will that automatically put it into the equation that it's relevant to? So like 89 value between.
Right, so good question. What is graphing calculator doing with W of 89? It goes, so I've named it F to graph, but back up here, it's looking at what I call W, and what is it doing? It's saying X is 89, therefore, it's between 0 and 128, so it's gonna put that into the first line and generate W based on that first line there, okay? And it got this number of something like 11.125 for the water height, okay? So that's why we had this if statement. So if X is between 0 and 128, that's what we got, 89, then it's gonna use line 1, and it's gonna generate that height, okay? Okay, so then what happens? The water keeps filling, more points on the graph, more points, points. Corresponding pairs of gallons and height. Every point in that graph is a corresponding pair of gallons and height. Okay, so tell the person next to you, what does this point mean right here? Go, what does that point mean? Okay. Tell me. This is not, so it may seem a little easy, but it's not trivial by any means. That you envision a graph this way. As our X increases, points, the graph emerges from points. The graph emerges from points as X increases. And in this case, that X increasing means we're adding gallons to our hot tub. So what does this point mean right now? What does this point mean? Someone in that back corner back there. Tell me. This is an easy one. All right, yeah. Okay, so is it just being a height? Is that point? I can't hear you. The point is the value of the function. What do we think? Agree with that? How about this corner? He says it's the value of the function. That's what that point is. Al, you were saying something. Point is the value of the output. True or false? No. What is it? Yeah.
Point is 404 gallons and the height of 404.
It's two pieces of information. It's the number of gallons and the corresponding height. That's what that point represents. What is the number of gallons? 404. What is the height? We could represent it, W of 404. We could use graphing calculator to find it. .42 inches. Okay, how does graphing calculator find this height? How is graphing calculator finding this height? It's taking 404 and it's seeing that between 128 and 550. It's using the second line, right? It's using the second line to generate that new water height of 28.42. Questions, comments? It's really important that you see graphs emerging from points, and every point is a packet of two things of information. It's x value and a corresponding y. In this case, the number of gallons and a corresponding height. It's crucial that you view graphs that way. It's just okay. So this is how we want to view how graphs come to be. One point at a time as x increases. And every point has this dual meaning of an x value and a y value taken together. Okay, so now I want to let's go back and look at this, the second line in the equation. So I'm going to pick off expressions from this, and you're going to talk about what they mean. Okay, so the first is, what is the meaning of x? What is the meaning of x minus 128? What's the meaning of 0.045? And then the whole thing. So you've got 5 expressions which have a value. So those expressions, as a whole, calculate a value. Okay? And so they represent a single quantity. What single quantity does each of those expressions represent in this second line of our piecewise function? So talk to the person next to you. What single quantity do each of those expressions represent? We need precise language. We need to nail it. Okay, go.
Yeah. The last one is changing. That's one
Okay. See, X is the total number of, or the current number of gallons added. It's the total number of gallons from when we started filling. Okay? It's a changing quantity. So the number of gallons is our X coordinate. How many total gallons have we put in the jacuzzi so far? What is X minus 128? This is really important. Exactly what is that quantity? Okay? Okay, it is a change in X, but specifically, what change of X is it? All the way back.
The number of gallons you have after you fill the bottom part.
The number of gallons, like the change in number of gallons after you fill the bottom part. Is that what you want?
Yeah. So something.
You can say it differently?
Yeah, just the number of gallons added to 120 gallons.
Number of gallons added after 128 gallons. Yeah, is that what you're going to say also?
The change in number of gallons
Between
between X and 128.
X and 128. Okay, so maybe from 128 gallons up to X. Right, it's a change in X. It's an added number of gallons from the step, from after when we had 128 gallons. So it's the change in gallons. Maybe from
start of the second step.
From the step, or from 128 gallons.
Could you say after 128 gallons?
Yes, that's even better. I like that better. Thank you. So it's basically the amount of water in the top part. It's the number of gallons in above the step in the top part. It's a change in gallons after the first 128 gallons are added. Okay, what do we get when we multiply that by 0.045? Yes, sir?
Change in Y?
Change in Y. Be more. So any change in Y? Which change in Y?
Change in Y after 120 gallons added.
Okay, so maybe let's compare it to height, though, instead of gallons.
Change in height after 128 gallons.
After 16 inches.
Yeah, so, yeah, go ahead.
So it would be the change in the number of inches after the amount of gallons has exceeded 128.
Right, exactly right. Okay? So it's the change in the height.
Since we're saying it's a change in the height,
Yeah.
Would we want to say that it's a change in the height after it has already increased 16 inches?
Yeah, so either way is okay. So you could say it's since the water height was 16 inches, it's a change in height since the water height was 16 inches, or it's the change in height since there was 128 gallons. Really, either is okay. And maybe one is preferred given a certain context, but they're both correct. It's the change in height after 128 gallons are added, or the change in height since the height was 16 inches. Okay, 16 is this number, this height, this is kind of the starting height for this piece of our function, right? So it's the height corresponding to 128 gallons, right?
The second step. Did you say that?
It's the height of the step. Yep, it's the height of the step, and so then it's our starting height for the second,
Yeah, it's the initial starting.
initial height for the new rate of change, like the initial height for the rate of change of 0.045. Okay, and then this would be?
New Y one, new height one.
Yep. Then this is, so if you take the change, so if this was the change since 16 inches, and this is the 16 inches from before, add them together, you get?
The new height one.
New height of the water. So that's how we get the output of the function in this second piece. You take the 16 inches from the bottom, you add the change, right? That's delta y. That's what this is. Because it's what? K delta x. So it's a delta y. Delta y plus old y. Familiar?
Yeah.
Right. Delta y plus old y gives you the current total height. So this is the height of the water from the bottom in inches. When X gallons are added in, when there's X gallons of water in it.
Say that it's not from the bottom,
Okay, is it from the last line? So is it from the step or is it from the bottom? Why is it from the bottom?
Including the
We
16.
added the 16. We added that 16 plus the change means the whole from the bottom. Because that's what the function outputs, right? The function outputs the total height of the water. And that rule, that's the whole rule for the second part. So it better give us total height of the water. And it does. 16 plus the change in height. Okay. So let's do it. Any more questions on this example?
Yes.
Please.
When we're defining x, we don't have to say that it's after 128, even though we're explicitly looking at the second equation. It's okay to just say total number of gallons. Or should we say total number of gallons added after 128?
Well, that would be the total number of gallons added after 128 is our x minus 128.
Okay.
So I think maybe what you want to say is total number of gallons added that is greater than 128. Or yeah, I know what you're saying. You're saying that x has to be.
I was just wondering if we have to be like that specific, since we're only looking at the second equation.
Yeah. So the implication is that value of x has to be greater than 128.
Okay.
Yeah. So but we don't have to write that in.
Okay.
Yeah. X is the total number of gallons added in. But you're right. In this analysis, it has to be a number greater than 128.
Okay, so it's just the one.
Yeah. Yeah, sure. Any other questions? Okay, so let's do an exercise based on this. So you're going to be writing, I'm going to give you some instructions here, and you're going to write, yeah, that's what I wanted there.
You shouldn't have your emails open.
I'm okay.
Calendars.
What's it?
Shouldn't have emails or calendars open.
Oh, students. I thought you were talking to me. Yes. Thank you very much. So here's some instructions for building a piecewise function. So I want you to see if you can write it out. Oh, shoot. There's one more thing I want to talk about in this. We're not ready for this. Look at, so this is really important. So look, forgot about this. This 16, where did it come from? Where? We know that the step is 16 inches high. But isn't that 16? Right. Yeah, it's an output of this for what number of gallons? Isn't this W of 128? So watch. I can change this function. I'm going to come in here and I'm going to put capital W of 128. And now we want to let's go ahead and graph W. Will it produce the graph correctly? Let's see if green shows up. Okay, so this is really helpful because we can, instead of having to calculate that number, let's let the first line of the function calculate it. So at the end of that interval, we get a height of W of 128. Well, that's where we want to be our starting height for the second part of the line. Okay, so this is something. So from here on out, when we make these piecewise function, this is what's called a recursive definition. Recursive. It's using something before to define something new. So to define this second line, we're using the function value at the end of the first line. right here. So this point right here, we're using that output, which we know is 16, but we can represent it as W128, and mathematically it is that starting y value from which we're going to get the new piece of the graph emerging. Okay. Does it make sense? Any question? Please.
Put the W128 in the if statement, or do you have to put 128 is less than X?
These are X values, right? This is a Y value,
Oh.
and these are X values, right? Make sense? Okay, let's try this exercise. Let's just go. Let's do the top hat. Okay, top hat is